Okay, let's have a look at exercise 25E from the IGCSE text. This is a year 11 text, but this one in particular I'm doing for my year 10 accelerate class. So I've been asked to find the correct answer to question 2. Now, we're going to use the cosine rule to do this. And the reason we're going to use the cosine rule works when we have an angle that either we know or we're trying to find out in between two known sides. We need these three components to either be found or being found. These are the key components here. And by doing that, we're then able to interact with the other side because the equation, I'm going to restate this actually, here we go. So here's my triangle. I'm going to make it a bit bigger so I've got room to maneuver here. So that's not very good, is it? Right, here we go. Whenever I change it to make it better, it actually ends up being slightly worse. Here we go. All right. So here is my triangle, such that it is. Now, we've got an 8 and a 9 and a 7. These are all in meters. And we've got to find angle theta. So there's my theta there, which now looks less like theta than it did before. We have the cos rule, which is a squared is equal to b squared plus c squared minus 2bc cos theta. Now, challenge here is we really want to make theta the subject. Now, if you knew that formula and you wanted to make theta the subject, we'll just quickly do that now, although I think it'd be reasonable that if they were going to give you a cos equation, they'd probably have one with theta as the subject. But if it's not the subject, it's a simple matter of rearranging it to land where we need to. So I'm going to just take this, I'll restate it actually. So I've got a squared is equal to b squared plus c squared. I'm going to rearrange it, write it again so I can play around with it a bit. I've got room to tease out how this is going to play out. So 2bc cos theta. First of all, I'm going to subtract b squared and c squared from both sides. Let's go ahead and do that. So I'm going to say minus b squared and minus c squared. Well, c squared minus c squared and b squared minus b squared are 0. Now I've got, on this side, I've got a squared minus b squared minus c squared is equal to negative 2bc cos theta. Well, now I can divide both sides by negative 2bc. Divide this by negative 2bc. And of course, negative 2bc divided by negative 2bc is 1. Leave me with cos theta. I'm going to write cos theta now on this side. Cos theta is equal to, and I'll rewrite this one. I've got a squared minus b squared minus c squared all over negative 2bc. Now, we don't really want the negative in front. So the best thing I can do is actually, if I was to multiply the top by negative 1 and multiply the bottom by negative 1, here we go. So times negative 1, and this is times negative 1. We're going to tidy it up a little bit because we want this to be as succinct as possible using the least amount of elements. In other words, the least amount of A's and B's and negatives and positives. We've got a negative here, which really is superfluous. We don't need that negative there. So if I do this, we end up with negative a times a squared is negative a squared, negative 1 times a squared, negative 1 times negative b squared is plus b squared, negative 1 times negative c squared is plus c squared, all over 2bc. So we've now got rid of the negative on the bottom, but we've now got one on the top. But I can just change this around a little bit. If I put that one over at this end here, I'm going to end up with negative a, sorry, my bad. Let's try again. Not good. All right, this is me not concentrating. Me just wanting to get to the end without actually doing everything else in the middle to get to the end. Okay, so now we've got cos theta is equal to b squared plus c squared minus a squared over 2bc. The nice thing about this is we've now got a situation where we've got only two signs. So we've got a plus and a minus. Before we had a minus and two pluses, but here before we had 3 minuses. So now we just got a minus and a plus. So we're now more succinct than we were, and we want to make theta the subject. So theta is equal to the arc cos of b squared plus c squared minus a squared all over 2bc. And that is how I'd express the answer. Now, of course, that's not any use to us in particular because we actually want to find out what theta actually is. So let's now populate this with the information that we need, which is we've got an A term. This is going to be my A. It has to be A because A has to be opposite the known angle or the angle we're trying to find, we're trying to know. And the other two sides are going to be B and C. This is, I'll call that B, I'll call that C. It doesn't matter, you can use them interchangeably. It doesn't matter which way around you get that. But theta now is going to equal, I've got arc cos of, and I'm going to call that 8 squared plus, C is 9 squared minus 7 squared, all over 2 times 8 times 9. All right, so all that comes to, so let's, so 8 squared is 64, 9 squared is 81, so I've got 64 plus 81 minus 49, all over, well, 8, 9, 72, 2 72s is 144. Cos running out of room here. What have we got here? 64 and 81 minus 49 should be 96 all over 144. And that is going to be 96 over one side. I can just divide that by, yeah, this is good. This is just going to be, that actually goes nicely in by 24, actually. Let's just check that. So I've got 96 divided by 24. Let's have a look. 4. Okay. 96. In fact, I'll just do it like this. 96. Here we go. Okay, 96. I'm just interested, actually. 96 over 144. What's that? Oh, it's 2/3. Right. Okay. That makes sense. Okay. So the arc cos of 2/3 is what we're wanting to find. Let's do that now. So arc cos, the arc cosine of 2/3. Here it is. And we get 48.18. I'm going to call that 48.2 because it asks for 1 dp. So 48.2. So I'm going to put is equal to 48.2 degrees. I'll put in brackets here 2 dp. And that's the answer.